See, moving water in a flood situation does all sorts of interesting things. There's a phenomenon called cavitation, which is what happened at the Glen Canyon Dam in Arizona. The water got moving too fast, and it sucked the sides of the rock right off the canyon wall. Within just about 20 seconds, it made an area the size of a basketball court, 4 feet thick, 4 feet deep, sucking rocks right off the side because of cavitation. There's another phenomenon called hydraulic plucking. As in addition to abrasion, moving water in the flood would pick up debris. And it's not just water moving now, it's liquid sandpaper. It's got gravel and rocks and mud and tree stumps and stuff in it. It's going to erode right through solid rock. It's going to abrade its way through rock. Also, there's a phenomenon called liquefaction. Liquefaction happens when sand grains are pressed and then the pressure is relieved. If you go out to the beach in Pensacola, walk out into the surf and stand there knee-deep in the water and just stand there for a while. As the waves come by, the high part of the wave weighs more than the low part of the wave, obviously. There's more water there. So the high part of the wave pushes down on the sand under your feet. When the low part comes past you, the pressure is relieved, and sand grains start hopping up off the bottom as the water squeezes out of them. This phenomena is called liquefaction. What would happen in a worldwide flood, as the earth is turning under the moon, you would get tides that would go up and down about 200 feet. A 200-foot tidal change every 6 hours and 25 minutes. So the liquefaction would be incredible worldwide because of this flood. It would raise the water 200 feet, which pushes on the sediments, and then the pressure is relieved, which causes all kinds of sorting to happen very quickly. One guy took a giant aquarium, and he put a hot water bottle in the bottom, a big rubber bladder with a bazillion little holes in it, and he hooked it to a hose. He put this in the bottom of his aquarium, empty aquarium, and then he took a cement mixer and mixed up rocks, gravel, sand, all kinds of stuff, mixed them together, including dead fish, amphibians, reptiles, and mammals. Mixed them all together and dumped them in the aquarium. When he turned the hose on, the aquarium began filling from the bottom as the water's going through this hot water bottle. Well, as it lifts up from the water coming up, it's going to automatically lift things and they're going to fall back down, liquefaction, and they're going to sort themselves by density. He discovered as it filled the aquarium, it sorted everything in the order of birds, mammals, reptiles, amphibians. Well, that's the order they're going to tell you they evolved in. If you just remember the word farm, F-A-R-M, fish should be at the bottom, fish, amphibian, reptile, mammal. That's what the evolutionists will say, how they evolved. No, they're not found in that order, number one, and if they are found in that order, liquefaction, or the flood, best explains it. There's a whole lot more on that in this book right here by Walt Brown. Also, as some layers are less dense, they get covered up by more dense layers. If the conditions are just right, the less dense layer will all of a sudden shoot to the top. It'll break its way through, and it calls what's called a sand plume. These sand plumes can harden, and probably Ayers Rock in Australia is a giant sand plume, best explained by the flood. If you look at these sand plumes closely, you'll see they have air bubbles all over them. That was the air. The tunnels all over them. That was the air coming out. And during an earthquake, the ground can shake and the water in the ground comes to the surface and the top of the ground can become like soup. There was an earthquake in Japan that sank these buildings. The buildings actually sank into the ground because of the phenomena called liquefaction. Water coming to the surface, settling, all the sand grains are all loose, almost like quicksand.